Okay, last time we were talking about roots of polynomial functions, and we looked at a function, for instance, like this, and we said, okay, you know what? Because of that degree, we're looking for no more than 3 zeros. That's the maximum amount that this function can have. Okay, let's go ahead and graph it and see what it actually looks like. So I went ahead to save time and I put the function in the calculator already. Now I'm going to hit zoom 6 so we can see that picture. This is what the graph looks like. How many real zeros do we see in this picture? Well, remember, a real zero is nothing more than an x-intercept. So it looks to me like we only have one real zero here. Well, that's very interesting because according to my paper here, it says that we're supposed to have at most 3. Well, I wonder what happened to the other 2. They're not imaginary. That's probably not the best word. They're complex. If you'll remember, we have a set of numbers. Our bigger set of numbers is called the complex numbers. So let's see, if I were to draw out kind of a quick sketch, I'd say, okay, this is the entire set of numbers here. It's called the complex numbers. Now, part of those are real numbers, and part of those are imaginary numbers. Remember talking about those before? When we combine the real numbers and the imaginary numbers, we end up with the set of the complex numbers. And if you'll remember, complex numbers are written in the form of a plus bi. A represents the real number part, and bi represents the imaginary part. Well, we have a fundamental theorem of algebra. The fundamental theorem, the core basic theorem in algebra says every complex polynomial function, some f of x, that has a degree greater than 1 or equal to 1 has at least one complex zero. So for instance, if you have a linear function, say 2x plus 5 equals y, then this is a straight line. It has one x-intercept. It's a degree 1 polynomial. If we had an x squared equation, then that could have at most 2 zeros, right? These we're now going to call complex zeros because they might be real or they might be imaginary, but they are complex. Well, to go further than that, we have a theorem that says every complex polynomial function of degree greater than or equal to 1 can be factored into n linear factors, not necessarily distinct. Remember, we can have multiplicities, where all of these factors basically give you complex numbers. That is, every complex polynomial where the degree is greater than or equal to 1 has exactly n zeros. A degree 3 polynomial will have 3 zeros. Some of them will be real, some of them may be imaginary, but they are 3 complex zeros.